On this lecture for digital image processing, we are looking at different ways to make sure our image is displaying properly and improving our visual interpretation of our image. Most of the time when you're downloading satellite imagery from Landsat or other large remotely sensed image data collection public data sites, the data will already have had some formatting and correction applied to it, some sort of blanket correction that they already do. So for example, Landsat science team will already georeference everything for you, and they apply broad strokes, general radiometric and atmospheric correction. I'm actually going to include a video from their science team talking about what they do, because I think they explain it better than I could. But this isn't always the case, especially as you start to perhaps work with remotely sensed image collected from a drone or from a private satellite company. You may just be given the raw data, and you will find a big difference between what you can automatically input into Envy or other GIS softwares in the quality of data right off the bat when you download a Landsat image or when you download and import a raw image data. So in the hands-on activities, we're mostly focusing on the correction that you're applying to Landsat imagery. So most notably conversion of digital numbers to reflectance values, so you can do actual meaningful analysis with it. But be aware that if you're getting the raw data from a source, you will be needing to do additional correction for it. We are also going to look at a series of image enhancements. So sometimes the data that you download, there are ways we can improve the quality of the image, how it's displayed, how we can distinguish between features, interpret features. These generally aren't permanent changes. They aren't changing the data. This is just changing how it's displayed. So let's go ahead and take a look at that. And I'll just walk you through some of the histogram stretch and contrast stretching that we can do in Envy. So you can get an idea of what that looks like. So here is my satellite image that we're using for, that I'm using for examples in this course. It's the Sioux Falls area. We're actually looking at, I looked this city up, Yankton, South Dakota here. And I thought it was interesting, this would be an interesting site to look at for our changing of our histogram contrast stretches because of the variety of vegetation, natural and farm vegetation, plus some urban areas, plus this part of the Missouri River with a lot of interesting things with vegetation and sediment that we can look at. Landsat imagery, especially Landsat 9 and 8, default to, I believe they default to optimized linear stretch in Envy based on what's written in the metadata. But what we're seeing here is this idea of contrast stretching, that the values that my screen can display for each pixel, we have the 256 different shades values that can be displayed from 0 to 255. That if we just use those values 0 to 255, we've had a very confusing image because it would be leaving out, and panicking my computer, but it would be leaving out a bulk of our histogram. A bulk of our data would not be able to be displayed by this contrast stretch. So hang on, let me figure out what's going on, why my computer's panicking. Oops, didn't want to data. Okay, well, it stopped. Okay, by applying the optimized linear stretch, we're seeing that we're taking that 0 to 255, those that series of the 256 values we could have for my bit depth, and stretching it across the histogram. So instead of 0 to 255, based on the type of stretch, it's going to apply a low value and a high value. There's also information on the exercises on what these all apply to and how they're created. But you can see as you move through them, even just moving optimized linear to linear, the amount of variation in your data, the width of how much data the 0 to 255 covers will change based on your stretch. So as we move from linear to optimized linear, our features got lighter. We see a little bit more variation. Our light features, a little bit more variation. Our dark features. We're also seeing more of the sediment transport within the river than in the darker original image. We can switch to some of the other one, equalization. Again, you're seeing the what's covered, how the 0 to 255 is applied for each of the bands. Again, we're seeing even more in the river. We're losing, the darker areas are just appearing really dark. So if you wanted to see something in the darker areas, maybe look for a different stretch. Here we're seeing a little bit more variability in the greens in this Gaussian stretch. Square root, I think, displays funny sometimes. Yeah, so a lot lighter. Again, if you were interested in maybe some of the sediment in these areas or something specific about these fields, this might be the best for you. But if we're just trying to display the contrast in the image, enhance it so we can see the different features better, you can go through and choose the best stretch method. So we can see how that changes, how it's changing what's represented on the histogram. And how that contributes to our image enhancement and what you can actually display.